Going on now to topic 2 of chapter 7. And you're going to see this ties in a lot with what we did in section 1 of chapter 7. Here we're talking about rational numbers as exponents. So these are fractional exponents. And we'll be going through all of these topics. So we are going to multiply a to the 1/2 power times a to the 1/2 power. Now that's going to give us, when we add 1/2 and 1/2, we get a to the 1st power. So this suggests, believe it or not, that a to the 1/2 is actually the square root of a. And let me show you how that works. So if this is the square root of a times the square root of a, this gives us the square root of a squared, because we just add these together, the radicands. And remember what we said, if you had a 2 there, this then becomes a to the 2 over 2. That is a. So a to the 1/2 power, let's look at that again. A to the 1/2 power, and I don't like the way they write it. I like to have it written this way. This is the fractional exponent way of showing this. Now this is related to a radical. The fractional exponents is another way of using the radical sign, where we say the index number goes right there. That's the denominator of your fraction. The exponent goes right there, and the radicand goes right there. So you see these two things are in fact related. All right, let's go on. So keeping in mind, and again, if you write the fraction in this form, 1 over n, I think it's a little more clear that the n is the index number, and the numerator of that fractional exponent is the exponent that we don't write if it's 1. Okay? And that's what they're explaining here. So, for some examples, write an equivalent expression using radical notation. All right, let's set it up. So we take a radical sign. Our base here is the radicand, and this is 1 over 3. Our denominator becomes our index number, and the numerator is our exponent. And again, we don't write the 1. So here we're going to put a radical sign. This is to the 1/2 power. And that 2 then goes here, but we don't write the 2. And this just goes 9 x to the 8th. Now, they're not asking us to simplify. They're just asking us to write an equivalent expression using radical notation. This is fractional exponential notation that we're converting to radical notation. So here we know it's going to be the radical sign. This is 1 over 5. Our denominator becomes our index number. Now it's a good thing if it's just to the 1st power, we don't have to put this in a parenthesis. But if it was to a greater power, we'd have to put that in a parenthesis and then put the exponent there. That's the first, that's the second. Now, notice they did simplify this one here. Okay, that's all right. And they also did some multiplication here. Again, let's review that because I didn't think they wanted us to do that. So there's 9 to the first power. So we're going to go 9 to the first times 1/2 gives us 9 to the 1/2 power. Now, 1/2 times 8 gives us 4. So notice now this is no longer part of our fractional exponent because our denominator is 1 of that exponent. So we do have then 9 to the 1/2 power, which is the square root of 9, and then x to the 4th. Then they're taking the square root of 9, which is 3. Okay, I would have done that, but they didn't indicate they wanted us to simplify. But apparently they did. And then again here, again putting it this way is a little confusing. 1/5. All right. All right, let's do this now because what they want us to do is to use exponential notation. So here's our radicand. So we have to put that in parentheses. And then it's 1, 3. Again, the index number is the denominator of our fraction. Now, why do I need to have parentheses? What's the difference between this and what I have there? Well, here, the only thing that has an exponent is the x. But again, they want all of this to the 1/3 power. That's why you needed the parentheses. So again, parentheses for all of this. 5y squared over x. And again, our denominator will be our index number. And our numerator is, this is all just to the first power. And there we go. And again, I don't like it written this way. It's a little confusing. Okay, so for any natural number m, nn, when n does not equal 1, and any real number a for which the nth root of a exists, this fractional exponent simply means, and again, let me write that in a proper way, it's m over n. The n is the index number. That's the denominator of our fractional exponent. And then it's raised to the m power. Now actually this is the preferred way to write it. This way would also be correct. But this is the preferred way where we put that exponent outside. And you'll see why in a little while. Okay, so here they are asking that we simplify it as well. So this is going to be the 3rd root of 8, the quantity squared, because this is 2/3. Index number, exponent. Now, what is the 3rd root of 8? Well, it's 2. And 2 squared is 4. So we are simplifying here. And then here, this is going to be 9 to the 3/2. This will then be the square root, the 2 going there, of 9 raised to the 3rd power. The square root of 9 is 3. 3 times 3 times 3 is 27. And again, you can always rewind the tape and play back if you miss something. I don't want to make them too long. Okay, write an equivalent expression using exponential notation, fractional notation. Well, again, this is going to be x to the 5th power. And we're going to just put our 3 right there. So this could be written x to the 5/3 power. And you don't really need parentheses. And here we need parentheses. 3xy. Our denominator will be the index number 5. And our numerator is the exponent. And there's that one. And there's that one. Now, negative rational exponents. We did a little bit of this in another course, and I don't know if they reviewed it for you, but here's basically what it means. And let me write it over here for you. If you have a to the negative m over n, that is equivalent to taking this base down to our denominator, because remember this is over 1 and there's also a 1 there. That 1 stays there to occupy the numerator position, but as this comes down across this division bar, the sign of the exponent changes, and this becomes then m over n. And in radical notation, that would be n a to the m. Now, it does give you this caution that because they have a negative exponent, that doesn't mean that this quantity is negative. That just refers to the position of the exponent. As it crosses the division bar, whatever sign you have here changes. That's the rule. So let's work these out. And again, I wish they would have written them properly. Okay, I've rewritten them so you could see it perhaps a little bit more clearly. Ooh, they all disappeared, didn't they? Hit the wrong button. Okay, so in letter A, keep in mind that this is over 1 and this is times 1. So the 1 stays in the numerator. This just comes down and it becomes the 3rd root of 8 squared. We're going to put that square out here. So the 1 stays there. Now what is the 3rd root of 8? That's 2. And then 2 squared is 4. So this becomes 1/4. Now for this one, the 9 is what goes down. The x to the 5th stays up on the top here. And I just converted that to its form. And then this is going to be the square root of 9 in the denominator. That's raised to the 3rd power. So this is the 5th root of x over the square root of 9 is 3, 3 to the third power is 27. Now, for letter C, I'm showing you a little trick here that when you have a fractional base and you have a negative exponent, to make this positive, you just take the reciprocal of this base. So notice here I flip them around. So this will then become the fourth root of 2r over 3t, and all of this will be raised to the third power. So it just saves the confusion of having to do all the changing around here. Because to make these positive, you just switch them around and then the sign of the exponent changes. So here it's negative. By flipping them around, it becomes positive. Okay. So there's A. That was good. B was good. Now notice they're leaving x in its fractional exponent form. I wrote it the fifth root of x. Okay, and if that's what they want, that's what you'll have to put. But the other one is equivalent. And by taking the reciprocal of this base, the exponent becomes, and they left it in its fractional form too. Okay. All right, we're going to go over some of the laws of exponents here. And by the way, all of the laws that we spoke of before hold true when they are in fractional form. That is, when we want to multiply, we just add the exponents. Want to divide, we subtract. Raise exponents to a power, we multiply, and the exponent applies to each of them. All right, so let's do some. So we have 7, and we're going to add 2/5 plus 1/5. We're just adding exponents, and you have to have the same denominators. So this becomes 7 to the 3/5. Use the law of exponents to simplify. Now, you could leave it this way, or if they wanted, convert it to the fifth root of 7 to the third power. And then here we have m to the 1/2. We're going to bring this up across the division bar. Its sign changes. And I need to do something with my denominators here. So I'm just going to make this a 2/4, which is equivalent to 1/2. So this becomes m to the 1/4, or the fourth root of m. Now here we need to multiply. So we're going to go x 1/2 times 3/4. So 1/2 times 3/4 is 3/8. And then this is going to be y to the negative 1/3 times 3/4 gives me a negative 3/12. Now, 3/12, and I could have done it here too. Can you see I could cancel that out? That's going to become 1/4 here. Otherwise, I think they would count it wrong. So 1/4. Now, if they want that positive, this would be the 8th root of x to the 3rd power. And then I just bring this down as the 4th root of y. Or this would just come down here as y to the 1/4. We'll see what they want. That's why you have to do some practice so you can see what they actually want. That one was no problem. This one was no problem. And they want it left in its fractional exponent form. It's a rational exponent form. Here they're showing us what they've done. And again, that's what they get. Because this became a negative, and then we brought it down to make it positive. Look how terrible it looks when they show them this way, but I guess that's the way they're doing it. Okay, let's go on. Here it says simplify radical expressions. We convert radical expressions to their exponential expressions. We use arithmetic and laws of exponents to simplify. Then we convert back to radical notation. Okay, so you might say, well, why do we have this? Well, so we can do some calculations. And I'll show you what we mean here. So this becomes 3x, that's my base, to the 2/4 power. And what is 2/4? Well, this simplifies to 3x, and again, that's in parentheses, to the 1/2 power, which then becomes the square root of 3x. Okay? So we said we could do that before. Take away the radical sign and just put the 4 under the 2. And that's what we have right here. So what are we going to do here? Well, we're going to take away the 3, the radical sign, put the 3 under there, so the 3 goes there, and that becomes then x y to the 2nd z to the 3rd power. 9 divided by 3 gives us our 3rd power. And then we just expand that, and it becomes x to the 3rd, y to the 6th, and z to the 3rd. So that little trick we mentioned in chapter 7.1 of taking away the radical sign, taking this index number, placing it under the exponent, it's a good little trick. Now this one we'll do in 2 steps here. This is going to be the 4th root of y to the 1/2. Okay? And then this is the y to the 1/2 raised to, keep in mind that outside here, there's just a 1, so the 1/4, like so. So this then becomes y to the 1/8. And I'll have to double check that I did that correctly. Okay, so we did that. And again, I don't like the way they've written that. Said that. All right, take the 3, place it under the 9, simplify that, and then that becomes the 3rd out there, and then we expand that, and it becomes this. Very good. Okay, I think I did that right. So this is y to the 1/2, and then this is 4 as a denominator, 1 is up there. We now multiply this, that gives us 1/8, and in its radical form, it's the 8th root of y. Very good. All right, that winds this up, and Good luck with your practice and later your quiz maze.